Hi everyone, today we'll be learning on a secondary to elementary mathematics topic called the Pythagoras Theorem and trigonometric ratio. So for pre-class preparation, now this video serves as an introduction to what is Pythagoras Theorem all about, where for the trigonometric portion I will then touch on more in class. So before we start the lesson proper, of course, let us go through once again the learning objectives for this lesson. Now you will get to learn how to solve problems using Pythagoras Theorem, and you'll be able to determine whether a triangle is a right-angled triangle given the lengths of the three sides, and explain what trigonometric ratios of acute angles are, okay, and find the unknown sides and angles in right-angled triangles, apply trigonometric ratios to solve problems in real-world context, including the angle of elevation and depression. Of course, the last 3 points will be more applicable for the trigonometric ratio subtopic, which I will only cover when I see you face to face for lesson. Okay, so for today, you just have to find out what is Pythagoras Theorem all about. Now, Pythagoras Theorem is quite straightforward. In a way, there is only one formula that you have to remember by heart, which is as shown here. Okay, c square is equal to a square plus b square. Now, this formula is only applicable to right angle triangle. So if you can see this triangle ABC over here, okay, the right angle triangle over here, as you can see here, okay, we can then apply the Pythagoras theorem. Now, I want to introduce you to a special side of the right angle triangle. I guess you may have noticed whenever you see a triangle that there's always the longest side of a triangle, and we call this the hypotenuse. Okay, in a right angle triangle, the hypotenuse is always the side that is opposite the right angle. So if you look at this triangle ABC, okay, angle ABC, okay, the one that I've highlighted already in red, this portion is the right angle, and the side that's opposite this right angle, which is the length AB, will then be called the hypotenuse. Okay, so we always denote the side opposite angle A as small a, the side opposite angle B as small b, and the side opposite angle C as C. So if you look at this diagram here, okay, because this is angle C, so opposite angle C, this side will be known as a small c. Similarly, this is angle B, so the side that's opposite angle B, the length will be given by a small b, and for A as well. Okay, so in a triangle ABC as shown here, given that this angle is 90 degrees, Pythagoras theorem will state that AB square, which is the hypotenuse square, will be equal to the sum of the square of the remaining two sides. So in short, c square is equal to a square plus b square. And this is the Pythagoras theorem. Okay, so it actually helps to prove if a triangle is a right angle triangle. So in a way, this theorem is only applicable for right angle triangles. So if you were to look at isosceles triangles or any other triangles, it is not applicable. Okay, not applicable. It's only for right angle triangles. So moving on, okay, now let's try this question. Now this is very fundamental. It really tests on the fundamental concept of applying the Pythagoras theorem into this question. Now in triangle ABC, AB is 5 cm. No, sorry, that's a typo. This should be AC. Okay, AC is 5 cm, BC is 12 cm, angle C is 90 degrees Celsius. Find the length of AB. Now, if you look at AB, it's directly opposite the right angle, and so this side AB is also known as the hypotenuse. hypotenuse. Okay, I'm just going to write in short hypo. Okay, so if you were to apply the formula as we have learned just now, c square is equal to a square plus b square. So in this case, our c square is the unknown, so we write c square, but we know that a square opposite a is actually 12 square plus 5 square. Okay, so I will then evaluate c square is equal to 12 square should be 144 plus 5 square is 25, and I will get, what's my answer? 169. Okay, so c square is 169. You have to evaluate c, okay, because c is determined by the hypotenuse over here. So you square root 169, and therefore the answer is 13 cm. Okay, it's pretty straightforward. So whenever you approach a problem, so long you can identify which is the hypotenuse and the two supporting sides and apply this formula here, you should be able to get the answer. Okay, of course there are different and varying difficulty levels of problems that you will approach, but the fundamental equation that you apply, the formula that you apply, will still be the Pythagoras theorem. Now I will just quickly go through this question in which you will then attempt yourself at home. Now in triangle ABC, okay, angle C is 90 degrees. P lies on BC such that BP is 21 cm, PC is 15 cm, and AP is 25 cm. Calculate the length of AC. So you're supposed to find what's the length of AC. So if you look at this triangle, it actually is a big triangle comprising of two smaller triangles. And if you were to be observant and sharp enough, you actually see that there are two right angle triangles. Triangle ABC and what? Triangle APC. Okay, these two are actually right angle triangles. So you say find the length of AC. So you see that APC is a right angle triangle and this is the hypotenuse. So based on the previous formula that we have learned, C square is equal to A square plus B square. And because 25 is the hypotenuse, which is opposite the right angle, so C square will be given by 25 square is equal to, okay, and then the two supporting sides, 15 square plus, let's say, B square, which is the unknown AC. Okay, so then you will evaluate out, okay, what is 25 square? Okay, 25 square is 625 is equal to 15 square is 225 plus B square. So you will know that B square is equal to 625 minus away 225, and you will get 400. Is that the final answer? No. You will then have to find what is B. B will be square root of 400. You will get 20 cm. Okay, so AC will be 20 cm. So long you know how to identify which is the right angle triangle, you know where's your hypotenuse, and you substitute into the different unknowns here, okay, you should be able to get the unknown sides. Okay, so if you're finding the hypotenuse, of course your C will be unknown, but if you're finding the unknown supporting sides of the hypotenuse, then these will be the unknowns that you will find. Okay, so for AB, I will leave it you to find it, but just to give you a quick tip, this is the triangle that you will look at, and in order to find this side AB, you will need to use this square plus this whole thing BC square will give you the hypotenuse square. Okay, so for that, I leave you to try yourself. Okay, now I want to go through perhaps something more difficult, like for example, okay, ABC is right angle triangle. AC is 43 cm, angle B is 90, H lies on AB such that HB is 15, and K lies on CB such that CK is 19 cm. Given that HK is 22 cm, find the length of AH. Okay, you're supposed to find this length. Now, once again, when you're doing Pythagoras theorem, always spot for all the right angle triangles that you can see within a figure. And for this, as usual, I think you will get to see two right angle triangles, HBK and ABC. So, based on this smaller triangle, okay, with 15 and 22, I can actually find this unknown KB here. After I find this, based on this whole length that I have, okay, and I know the hypotenuse of this triangle, so AC square minus away CB square will give me AB square. And then I find my AB, okay, and then after I find AB, I minus away 15, I will get my AH. Okay, so I'm not going to write the workings out here. You have to do it yourself at home. So please, okay, for part 2 application of Pythagoras theorem, we will then cover in our lesson when I see you face to face. Okay, but at home, can you please complete, okay, from question 1 all the way to question 6, okay, in which I'll go through the answers with you in our next lesson. Okay, so just to wrap up today's lesson, is pretty straightforward. There's only one formula that you have to know, which is the Pythagoras theorem. Okay, and the formula is c squared is equal to a squared plus b squared. It's only applicable to right angle triangles, where you can use this law to prove any triangle if they are right angle triangles. Okay, so remember that your c squared is always determined by the hypotenuse, which is always the side that is opposite the right angle. Okay, so okay, that's all for today. So I hope you have learned something about Pythagoras theorem, and please remember to do the necessary pre-class homework and preparation before I see you on your next lesson. Okay, with that, I'll end this lesson today. Thank you.